1.4 is solving absolute value equations. When we are going over these equations, you want to keep in mind a few things. First is the absolute value of any number is the distance between that number and 0 on a number line. So you got to think to yourself, the number that you're solving for a lot of times is the number inside the absolute value bars, which means you need both possibilities of what that number can be. You could have a positive number and a negative number inside those absolute value bars. So when your variables inside the absolute value bars, you're solving really for both a positive number and a negative number. So you want all possibilities with these. So with each of these equations, when we solve them, we are actually going to be setting up two equations. Our first thing to do is to isolate the absolute value. Once the absolute value is by itself, we can form two equations by getting rid of the absolute value bars, keeping the answer term the same, and then taking the opposite of it as well. So what does this mean? If we look at example 1, we have for A, the absolute value of x minus 4 is equal to 6. Remember, when you're solving for the absolute value of anything, it's always a positive number. With this one, since it's equal to a positive number and our absolute value is already by itself, we can turn this into two equations by taking the absolute value bars away from this and writing it as just x minus 4 is equal to 6, as well as x minus 4 is equal to the opposite of 6, which is negative 6. So x minus 4 is equal to negative 6 as well. From here, we're just solving for x for both equations, and we're going to have two answers. So for the x minus 4 is equal to 6, we're going to add the 4 to both sides. We get that x is equal to 10. And then for the x minus 4 is equal to negative 6, we add the 4 to both sides and get that x is equal to negative 2.
Wait, why did we do both?
So when you have the absolute value of a number, it could be either a positive number that's on the inside of the absolute value bars or a negative. So we want both possibilities of what that value can be. So you got to think, let's say the absolute value, we're taking the absolute value of x, and it's equal to, I should be doing another question, but let's say that it's equal to 5. We want both possibilities of what that x can be. So if we take the absolute value of 5, we're going to get 5. However, if we take the absolute value of negative 5, it's also 5. So we're doing both possibilities here.
Okay, thank you.
You're welcome.
For the one with the negative 6, wouldn't the answer be negative 4?
No. Why would it be negative 4? You move the 4 over by adding it to both sides. So you're doing negative 6 plus.
I don't know why I put 10.
It's all right. So if we look at B, B is a little different. You have the absolute value of 3x plus 1 is equal to negative 5. Can the absolute value of any number be equal to a negative number? No. So because this negative 5 is what this absolute value is equal to, this is impossible. You cannot have the absolute value of any number equal a negative number. So this is no solution. So you always want to look at your equation. If you ever have an equation where it's the absolute value is isolated and it's equal to a negative number, You don't have to do anything to it. You just got to give me that there's no solution. So the absolute value of anything can never equal a negative number. If you have an equation where the absolute value is by itself and it's set equal to a negative number, automatically no solution. For C, we have the absolute value of x is equal to 10. So we have the absolute value by itself. It's equal to a positive number. We're good to go. We can separate this into two equations, getting rid of the absolute value bars, taking it as x is equal to 10, and x is equal to the opposite of 10, so that's negative 10. X is by itself, so these are our solutions. For D, we have the absolute value of x minus 1 is equal to 4. The absolute value is by itself. It's equal to a positive number. Translate it or transform it into two equations. So we're going to have x minus 1 is equal to 4, as well as x minus 1 is equal to negative 4. And now we're just going to solve for x for both. We're going to add 1 to both sides. I'm going to work with the equation on my left first. So I add the 1 to both sides, my x drops down. So x is equal to 5. I move the 1 over on the other side as well. So I add it to both sides. They cancel out. And x is going to give me negative 3 as well. So I have two solutions, one that's 5, one that's negative 3. For E, we have the absolute value of 3 plus x is equal to negative 3. My absolute value is by itself. However, it's set equal to a negative number. Now, the absolute value can never equal a negative number, so my answer is automatically no solution. For example 2, we have the absolute value of 3x plus 9 minus 10 is equal to negative 4. We have to isolate the absolute value first. So that minus 10, we have to move to the other side so we can add it to both sides. These 10s are going to cancel. We're going to drop down the absolute value of the 3x plus 9. The absolute value of 3x plus 9 is equal to 6. Remember, negative 4 plus 10 is the same thing as 10 minus 4. From here, we're going to get rid of the absolute value bars. We're going to form two equations since the absolute value is by itself and it's equal to a positive number. So this is going to leave us with 3x plus 9 is equal to 6, as well as 3x plus 9 is equal to negative 6. So I'm going to work with my equation on the left side here. So the 3x plus 9 is equal to 6. I'm going to subtract the 9 from each side to get the 3x by itself. The 3x drops down. We have 3x is equal to negative 3. Then we divide each side by the 3 in front of the x to get that x is equal to negative 1. Now, when I'm looking at this, my equation does not have an x on the equal to side. So my negative 1 for my solution is going to be fine since that's going inside the absolute value bars. If it was something like the x was on the outside, on the other side of the equal sign with the 4. So if it was, let's say, negative 4 times x, it would still be okay. But if it was positive 4 times x, then we'd have a problem because then it would be that the absolute value of something is equal to a negative number. So you always have to check these to make sure where your x is to see if your answer is a possibility. So I still have to solve for my second equation that I formed, that 3x plus 9 is equal to negative 6. So I'm going to subtract my 9 from each side on this one. My 3x will drop down. It's going to be 3x is equal to negative 15. We then divide each side by the 3 to get x by itself. And we have that x is also negative 5. So my two solutions for this one is negative 1 and negative 5. You can also, just like regular equations, plug in your answers to see if you get true statements. If you do, then you know your answers are correct. For our next example, we have the absolute value of x minus 2 plus 5 is equal to 9. So first, we have to isolate that absolute value. We're going to move the 5 over by subtracting it from each side. This is going to leave us with the absolute value of x minus 2 is equal to 4. The absolute value is by itself. It's equal to a positive number. I can keep going. I get x minus 2 is equal to 4, as well as x minus 2 is equal to negative 4. From here, just solve for x. So with my equation on my left side, I'm going to add my 2 to both sides, drop down my x. So I have x is equal to 6. For the equation on my right side, I'm going to add the 2 to both sides, drop down my x, and we get that x is equal to negative 2. For B, we have 4 times the absolute value of 2x plus 7 is equal to 16. So again, we're going to isolate that absolute value. We're going to divide each side by the 4. The 4's cancel out. We're left with the absolute value of 2x plus 7 is equal to 4. The absolute value is by itself. It's equal to a positive number. Form your two equations. You have 2x plus 7 is equal to 4, as well as 2x plus 7 is equal to the opposite of 4, so negative 4. Solve for x in both equations. Start by moving the 7 over, subtract it from each side. With the equation on the left, you're going to have 2x is equal to negative 3. From here, we're just going to divide each side by the 2. And you get that x is equal to negative 3 over 2. For my equation on my right, I'm going to subtract the 7 once more. Drop down that 2x. This is going to leave me with 2x is equal to negative 11. From here, I'm just going to divide each side by the 2 to get x by itself. And I have that x is also negative 11 over 2. For C, we have negative 2 times the absolute value of 5x minus 1 minus 3 is equal to negative 11. We're going to start by adding this 3 to both sides. 3's cancel out. I bring everything else on that side down. So I'm going to have negative 2 times the absolute value of 5x minus 1 is equal to negative 8. From here, we just divide each side by negative 2. The negative 2's cancel out. We're going to be left with 5x, or sorry, the absolute value of 5x minus 1 is equal to 4. The absolute value is isolated. It's equal to a positive number. Form your two equations. You have 5x minus 1 is equal to 4, as well as 5x minus 1 is equal to negative 4. From here, solve for x. Add your 1 to both sides. Drop down your 5x. This is leaving you with 5x is equal to 5. Then from here, divide each side by the 5 to get x is equal to 1. Work with your other equation now. You have 5x minus 1 is equal to negative 4. Add your 1 over to each side. Isolate that 5x. We have 5x is equal to negative 3. From here, divide each side by the 5 to get x by itself. So you have x is equal to negative 3/5. We're going to skip example D because I'm not going to be giving you word problems with these. And we're going to move to solving these absolute value equations where there's absolute value on both sides. When you're doing this, you're doing the same exact thing that you were just doing, except now you have to take into consideration if there's multiplication. If there's multiplication happening like in example B here, we put parentheses around that absolute value and distribute a negative inside of it. We're only doing that negative on the left side of that equal sign. So first, let's look at example 4a. We have the absolute value of 3x minus 4 is equal to the absolute value of x. When we do this, we are going to separate this into two equations. So we just are going to have 3x minus 4 is equal to x, and then apply that negative to the left side of the equal sign. So then it's going to give you 3x minus 4 is equal to a negative times x. From here, solve for x in both equations. Start with the one on the left. We are going to subtract the 3x from each side. This is going to leave us with negative 4 is equal to negative 2x. Then from here, divide each side by the negative 2. The negative 2's cancel. You have x is equal to a positive 2. For your other equation, you have 3x minus 4 is equal to a negative times x. The negative times x is negative x. So that's just 3x minus 4 is equal to negative x. We are going to move the 3x over by subtracting it from each side. So negative x minus 3x is negative 4x. We drop down that other negative 4. we get negative 4 is equal to negative 4x. We divide each side by the negative 4. And we get that x is 1. So again, you have two solutions here. One that's the 2, one that's the 1.
Miss Glick, can you stop for a second so I can copy that down?
Yeah,
Thank you.
you're welcome.
Why would we add the parentheses to the x next to the negative if it's like
That way we know
not really affecting it?
it's just that way we know to multiply it, the negative to whatever's was in that absolute value. So like if you look at B, when you do B, you're not going to apply that negative to the 2 that's in front of the absolute value. You're just applying it to what's inside the absolute value, which is why I'm going to put parentheses around the 3x plus 1 and then put a negative in front of that. But it doesn't mean 2 minus the 3x plus 1. It's going to make a little bit more sense when I actually write it down for you so you can see. I just want to make sure everybody can copy down example A before I move on to B and show you that.
All right, thank you.
Okay, so for example B, we have the absolute value of 4x minus 10 is equal to 2 times the absolute value of 3x plus 1. I'm going to rewrite this two different ways. One, that's just the same exact way that you see, except I'm going to get rid of my absolute value bars and put parentheses wherever they are. The other way that I'm going to do it is I'm going to distribute a negative onto the the right side of that equal sign. But when I do it, I'm only distributing the negative into what's inside the absolute value bars. Okay, so this is going to turn into one equation that's 4x minus 10 is equal to 2 times 3x plus 1. And then another equation that's 4x minus 10 is equal to 2 times a negative times 3x plus 1. So again, I'm only distributing that negative into what was inside the absolute value bars on the right side of that equal sign. So I'm going to first work with the equation on the left. First thing I do is distribute the 2 into the set of parentheses. So I'm going to have 4x minus 10 is equal to 6x plus 2. Now I'm going to solve for x. I want to move my 4x over so that way my coefficient of my x is positive. I subtract it from each side. The 2 is going to drop down. The 10 is going to drop down. The 4x's cancel. So this is leaving me with negative 10 is equal to 2x plus 2. From here, I'm getting my 2x by itself, so I'm going to move this constant 2 over by subtracting it from each side. My 2's cancel out. My 2x drops down. Negative 10 minus 2 is negative 8. Negative 12. And that's equal to 2x. From here, I'm just going to divide each side by the 2 to get x by itself. And we have that x is equal to negative 6. For my other equation, the one on the right side, I'm applying a negative. I'm taking the opposite of what's inside those absolute value bars. So I put parentheses around the 3x plus 1, and I distribute a negative into there. This is going to leave me with 4x minus 10 is equal to 2 times negative 3x minus 1. Remember, when we distribute that negative, we're just changing the sign on everything. From here, I distribute the 2 into that set of parentheses. So this is going to give me 4x minus 10 is equal to negative 6x minus 2. Now, all I have to do is solve for x. I'm going to move my 6x over by adding it to both sides. These 6x's cancel. My -2 drops down. My -10 drops down. This is leaving me with 10x minus 10 is equal to -2. From here, I want to add the 10 to both sides to get my 10x by itself. My 10's cancel. My 10x drops down. We have 10x is equal to 8. From here, I'm just going to divide each side by the 10 to get x by itself and simplify. And I get that x is 4/5. So my two solutions for this one is -6 and 4/5. For example C, we have the absolute value of x plus 8 is equal to the absolute value of 2x plus 1. So again, I'm going to get rid of my absolute value bars for my two equations. I have x plus 8 is equal to 2x plus 1, as well as x plus 8 is equal to the opposite of 2x plus 1. From here, I'm going to solve my equation on my left side first, so that x plus 8 is equal to 2x plus 1. I'm going to start by subtracting my x from each side. My 1 is going to drop down, my 8 drops down, and my x's cancel. So I have 8 is equal to x plus 1. From here, I'm going to subtract my 1 from each side, and I get that x is equal to 7. For that other equation, I have x plus 8 is equal to the opposite of 2x plus 1. So I'm going to just distribute that negative. This is going to give me x plus 8 is equal to -2x minus 1. I want to move my 2x over. So I'm going to add it to both sides. This is going to drop down my -1. My 2x's are going to cancel, and my 8's going to drop down. So I'm left with 3x is equal, 3x plus 8 is equal to -1. From here, we subtract 8 from each side. The 3x drops down. So 3x is equal to -9. We then just divide each side by the 3 and get that x is also -3. For D, we have 3 times the absolute value of x minus 4 is equal to the absolute value of 2x plus 5. So again, I'm just going to get rid of my absolute value bars, turn them into parentheses. So I'm going to have 3 times x minus 4 is equal to 2x plus 5. If it helps to write parentheses around them, write parentheses. I'm also going to have 3 times x minus 4 is equal to the opposite of 2x plus 5. So I'm going to work with my equation that's on my left first. So the 3 times x minus 4 is equal to 2x plus 5. I'm going to start by distributing the 3. So this is going to leave me with 3x minus 12 is equal to 2x plus 5. From here, I'm going to subtract my 2x from each side. So this is going to leave me with x minus 12 is equal to 5. From here, I just add my 12 to both sides and get that x is equal to 17. Now for my other equation on the right side, I'm going to distribute the 3 as well as that negative on the other side of that equal sign. So this 3 times x is 3x, 3 times negative 4 is negative 12, is equal to a negative times 2x is negative 2x, and a negative times 5 is negative 5. I'm going to move that 2x over first by adding it to both sides. Cancel out on the right side. The negative 5 drops down. The negative 12 drops down. So we have 5x minus 12 is equal to negative 5. From here, I just add my 12 to both sides. My 5x drops down. My 12's cancel. I'm going to have 5x is equal to 7. From here, we just divide each side by the 5 and get that x is 7/5 as well.
Why do we put the parentheses around them?
So I do that so that way I know that whatever I have to distribute in is getting multiplied by it. If you just put the negative out in front of the 2x plus 5, and like when you did your second equation, you wouldn't be distributing the negative to both 2x and the 5, and that's going to mix you up and get your answer wrong. So you want to make sure that you distribute the negative into that absolute value or whatever's in the absolute value on the right side of the equal sign.
Oh, okay, I see. Thank you.
You're welcome. So just like with equations without absolute value, equations with absolute value also have special circumstances. So that means where one answer is not going to work out of the two, or when you have like no solution for them. So if you look at example 5, we have the absolute value of 2x plus 12 is equal to 4x. Your absolute value is isolated. It's equal to a positive. We're good so far. We're going to separate this into two equations. First one's going to be the 2x plus 12 is equal to 4x. Next one's going to be the 2x plus 12 is equal to the opposite of 4x. So I'm just going to multiply the negative to the 4x. I'm going to work with the equation on my left. I'm going to subtract the 2x from each side to get 12 is equal to 2x. From there, I'm just going to divide each side by the 2 to get x by itself. So x is equal to 6. For the other equation that I wrote out, I have 2x plus 12 is equal to the opposite of 4x. So that's 2x plus 12 is equal to negative 4x. From here, I'm going to move my 2x to the other side, so I'm going to subtract it from each side. I get 12 is equal to negative 6x. I divide each side by the negative 6, and I get that x is equal to negative 2. Now, you need to think about your answers here. That x is equal to negative 2 means that the absolute value of something is equal to 4 times negative 2. Well, that means that the absolute value of a number is equal to a negative 8. Is that a possibility? No, it's not. So this negative 2 is called an extraneous solution. So what that means, whenever you have an extraneous solution, it means, yes, you get it as an answer. However, that answer doesn't work. So negative 2, you got as an answer, but it doesn't work when you plug it back in. When you have extraneous solutions, they're not included in your solutions. So if this was a test or a quiz question, the only thing that you would give me for your answer is the 6. If you gave me the negative 2, the entire thing would be wrong because it's an extraneous solution. It's not part of the solutions. So extraneous solutions just means that, yes, you get it as a solution, but it's not a solution that works. So you would not include your extraneous solution in your answer. If we look at example 6, we have the absolute value of x plus 5 is equal to the absolute value of x plus 11. So we're going to rewrite this without those absolute value bars. We have x plus 5 is equal to x plus 11, as well as x plus 5 is equal to the opposite of x plus 11. So with my equation on the left side, I'm going to subtract my x from each side, and I get 5 is equal to 11. Well, that's a false statement. So this one we're not going to work with. 5 is not equal to 11. So we don't work with that one. Just forget about it. For your equation on the right, you have x plus 5 is equal to a negative times x plus 1. So the opposite of x plus 1. Start by distributing the negative into the second set of parentheses. You have x plus 5 is equal to negative x minus 11. From here, you can add your x to both sides. So this is going to leave you with 2x plus 5 is equal to negative 11. From here, we can just subtract the 5 from each side. We drop down that 2x. So 2x is equal to negative 16. We then divide each side by the 2. We get that x is equal to negative 8. Now you think, look back at your equation. My x is inside absolute value bars, so it is okay that it's a negative. So your only solution for this one is the negative 8. If we look at our next example, we have the absolute value of x plus 6 is equal to 2x. So I'm going to get rid of those absolute value bars. I'm going to have x plus 6 is equal to 2x, as well as x plus 6 is equal to the opposite of 2x. So I'm going to move my x by subtracting it from each side. And the first one that I get is 6 is equal to x. 2 times 6 is 12. It's positive. We're okay with that. With my second one, I apply my negative or my opposite of 2x. That's going to give me x plus 6 is negative 2x. I subtract the x from each side. This is going to leave me with 6 is equal to negative 3x. I then divide each side by the negative 3. And we get that x is equal to negative 2. Now, you got to think back again. X is equal to negative 2. If 2 times negative 2 is negative 4, can the absolute value of anything equal a negative 4? No. So this is an extraneous solution. You do not include this. For B, we have the absolute value of 3x minus 2 is equal to x. So this is going to leave us with 3x minus 2 is equal to x, as well as 3x minus 2 is equal to negative x. To solve this, I'm just going to move my 3x over by subtracting it from each side. I'm going to have negative 2 is equal to negative 2x. We can divide each side by the negative 2. They cancel. So that way you're just left with x is equal to 1. We have a positive number there, so we're good. We don't have to worry about it. For the 3x minus 2 is equal to negative x, again, I'm going to subtract my 3x from each side. This is going to leave me with negative 2 is equal to negative 4x. I then divide each side by the negative 4 to get x by itself. My negatives turn into positives because it's a negative divided by a negative. And I get that x is equal to 1/2. For C, we have the absolute value of 2 plus x is equal to the absolute value of x minus 8. So again, I'm just going to get rid of my absolute value bars. I have 2 plus x is equal to x minus 8, as well as 2 plus x is equal to the opposite of x minus 8. I'm going to move my x's over by subtracting them from each side. So this is leaving me with 2 is equal to negative 8. This is not a true statement, so I'm going to forget about this one and not work with it any further. I'm going to work with my other one. So with the other one, I'm just going to distribute that negative. This is going to give me 2 plus x is equal to negative x plus 8. I move the x over by adding it to both sides. This is going to leave me with 2 is equal to 2x is, 2 plus 2x is equal to 8. I then just subtract the 2 from each side. This is leaving me with 2x is equal to 6. I divide each side by the 2. So x is 3. So my only answer for this one is the x is equal to 3. For D, you have the absolute value of 5x minus 2 is equal to the absolute value of 5x plus 4. This is just going to be 5x minus 2 is equal to 5x plus 4, as well as 5x minus 2 is equal to an opposite of 5x plus 4. So work with the one on the left with me. I subtract the 5x from each side. This is just leaving me with negative 2 is equal to 4. Again, that's not a true statement, so forget about this one. Don't pay attention to it. Work with the other. Distribute the negative. This is leaving you with 5x minus 2 is equal to negative 5x minus 4. We add that 5x to both sides. These cancel. The negative 4 drops down, the negative 2 drops down. So we have 10x minus 2 is equal to negative 4. We add the 2 to both sides. The 10x drops down. So 10x is equal to negative 2. Then we divide by 10. And get that x is equal to negative 1/5. Now again, you look back at your question that you originally started with. Your x is inside the absolute value bars. It's not on the outside, so that's okay. We are perfectly fine with that negative being our answer.